Alright, so today we have this fucked up speaker, which apparently has a fucked up micro USB port, which it does indeed have. So this shouldn't work too well. And yeah, so the mission here, by the way, this feels very chunky. I mean, Sony really puts a lot of money into everything. Yeah, so first things first, let's check if there are any resources on how to actually open this. Usually you just unclip the stuff, but yeah, so again, the guy on YouTube, I'm just gonna give him a thumbs down right now because I did actually break one of my clips. So the way you're supposed to do this is push the grill, push the mid grill outwards, so kind of like this. Quite a bit of force, and then they do come out like absolutely not at all lifting, which is what I did, and I actually did break one of the feet, or did I? All right, so very nice design. 2 passive radiators. So as far as the other grill is concerned, I'm not sure we have to get it off, but we'll try. Okay, so the back side is actually glued in. All right, so I wonder if releasing the speakers will also release this top section. Seems to have a seal all around the edge. Like, why would you have such a big seal in your product? I don't know. Wonder if this is gonna start leaking once I get my hands around it. By the way, these wires are very nice. Man, I don't think I've seen these before. Right, so plus shaped wires. Very nice. Very nice. I mean, Sony really does a good job. Ink writers for what? Like, probably 10 years by now. Eventually, Remarkable did come along, right? The other e-ink writing tablet companies, but Sony was out there making it regardless, right? Before it became economically viable. How am I supposed to take this apart, man? This is just super weird. All right. I have to say this is quite uncomfortable. Okay. Let me try and zoom in. Right, so they have these plus signed wires. Oh my god, these are so nice. Just that they don't bang that hard against the case, right? It's such a small product. How you can definitely hear wires rattling, but right, so in order to get to the charging board, which even has some buttons. Again, Sony, right, a reset button like this, they really do not care about costs, man. Like, this is just outstanding. I am happy they do make stuff. I do actually feel fortunate that a company like Sony does exist. Oh my god. Alright, so there's one more connector that we need to actually disengage. Seems to be a regular pull type connector. I hope it is at least. Okay. So there's basically this board which we need to somehow change the port on. I was actually planning on swapping in some Type-C magic, but it's looking quite difficult. Let me see. If I want to keep the jack, which I definitely do, have to find a way. Let me see. Let me think. Right, so at the moment, the plan is the following. We have this daughter board here, which we could probably ask Sony to sell us. That's going to probably not go so well. And so this goes in right here, and you can see there's absolutely no gasketing around here. That is because this piece of plastic, which goes on like this, actually does have a gasket, and then this comes flush over here. And so anyway, Sony really spending a lot of money with this shit. But what I'll try doing is actually carve a lot of this board out and actually try mounting it like this, which might work, although we'll see. Worst case, I'll have to chop some of this off. I should be fine. All right, so let's get to doing the stuff I said, and I'll probably be speeding stuff up. Right, so using the diamond disc on the Dremel, I actually got this a tiny bit smaller. Right, so originally they would look like this. And I'm just interested in basically getting to the Type-C out. I'll be soldering either these copper wires or something thinner to this board. But right now I have to even cut some of the pillars out. Right, so I'll be using that orifice over there, most likely with the board this way, so it clears this other board over here. Something like this. And yeah, for that, I will also have to, let me see if I can remove the plastic. All right, so for this, what we'll be using, although someone said that a great way of, someone in the comments in my videos said that a great way to deal with Type-C is to drill 2 3mm holes. And as you can see, the guy was kind of right. So this is kind of a 3mm shaft, and so 2 holes and then you widen them. But in this case, I don't know, yeah, I'll just, yeah, it's just faster this way. All right, so it doesn't look particularly good, but I think we can help. All right, so it's gonna look something like this, which, yeah, not super bad. All right, so next up, I'll be reinforcing the connections onto this board because last thing I want is for this to also fail. You can see they went super light on the solder. Then we're gonna get a plus and a minus, and then we'll go from there. All right, so now it's time to measure and see where exactly we can hijack the plus connection. So I have one of these simple power banks which will always output 5 volts, no matter the load. It's one of the first designs with discrete chips. Pretty cool. Right, so I'm guessing that this middle connection is the positive voltage or the lower one. Let's see. All right. And how about this? Same. Okay. So we'll just have to scratch some of that off, get some wires onto it, and that'll be it. All right, so this would be the Type C daughter board with beefed up connections on the side. Red would be positive. So let's see. Yeah, okay. Everything good now? Yeah, should be fine. All right, so now that that is sorted out, we can actually focus on tracing out where plus and minus go over here. I would imagine right side would be minus, given that it goes to the ground plane. But yeah, I'll do some checks. So let's see. So I would say this would be chassis. All right, and then I would say that this is negative. Okay, and this. All right, so that leaves this for positive. Okay, so this would be the final assembly, so to say. I had to move where the wires were connected because over here the board will be kind of like this, and so it needs to come really close to the existing this existing daughter board, and I did move them upstream. So this transistor, whatever it is the same as the plus, and I've just scratched another bit of the ground plane over here at the top. What I'll do now, though, right before all of that, is I will check if it actually works, right? Right, so they went with an extremely complicated construction on all of this. I mean, cost cutting was definitely not top 10 priorities on this project, which is kind of cool. It does seem like they're pissing away a lot of money, though, so I don't know. It's just 2 boards for what? For 3 buttons, and they couldn't get this on the same board. I mean, I don't know. I don't know. It seems they're just too chill, but maybe that's just me. All right. right, so let's pop this in.
I don't know if I'm going to keep doing these if life keeps dealing me cards like this.
So it's only going to go 0.2 watts, not even, right? 0.15. So it is definitely going at it, but not actually charging. So next up, you would suspect that maybe the battery is super dead and it's going into a revive mode, but that is also not the case. So if we measure the cell, we're going to get 3 volts, which is nowhere near like dangerously low, so you have to revive it. So next up, I did actually notice or remember noticing. So the data wires are actually taken out. You can see them over here. Lighting is super bad and now there's flux. But anyway, there's 2 wires coming over here. There are 2 what I think are capacitors, these parts that are at a weird angle. And then they go through 2 capacitors or 2 resistors, are 151 and 150. And then they go sneak off to the board. And then what I think happens is the microcontroller is checking to see what kind of a wire is plugged in, right? So we see voltage. What the hell is that? And if it doesn't see anything on the lines, it's gonna assume some fault state, right? So what you can do is basically bridge across the wires, because this is what the 2 amp chargers do. So if you want to indicate 2 amp charge over regular 4-wire USB, you basically just short the data wires, right? The charger would short the data pins. So as I've mentioned, I've broken off these pads like an idiot, but hopefully I've bridged the correct 2 ones. So these would be the data wires, and now the speaker will always think that it's connected into a 2 amp charger. So okay, so before we had 0. whatever watts. Let's see now. All right, so now it does enable charging and it does start pumping power into the battery, which incidentally is 118,650. Okay, so that being said, the last step of this process would be to actually stick this down into the case and make everything go back together. What we also need gone is this tiny pillar over here. So I think I'll just drop some hot snot in here, just because it dries out incredibly quickly, and it is also reworkable, right? So if you want to undo some hot snot, you just warm it up, and it does usually all come off in one piece. So that is very desirable. Right, so I'll set up the hot snot, and then we'll be back pouring and then wrapping shit up, and then it should be done. All right, so we're ready for the pour. How am I going to do this? I think I want some sort of a holding this type C connector in. And I'm going to be using this right angle through. Should be fine. All right, so I think that's about it. Let's close up the front grille. Is this the top? Yes, it is. All right, so basically what we have done here is added Type-C to this Sony Bluetooth speaker. Not the prettiest hold, not the prettiest job, but it should work. Let's give it a quick test. And again, this will require USB Type B to Type C cables, right? Type C to Type C will not actually work because this has absolutely no facility to trigger the Type C charger to actually output voltage. Right, C to C wires actually require some communication before the power gets established. So anyway, let's have this plugged in over here. All right, so it's charging, and let's see the other way. All right, so it does work. Let's see if the speaker powers up. It seems to work fine. I'll report back if I've busted anything super critical. But apart from this, I hope you guys can fix yours, and do go ahead and opt for Type-C because it is way, way better. Connector is way more robust. And yeah, it is a fairly involved job, but it was good fun. Right, so this should still have quite a lot of years of service. And when the battery craps out, it's a simple 18650. That'll be another like 10 minutes to change. So yeah, have a good one.